Hi everyone, myself Orkojyoti, and in this video we are going to solve the question 3403, find the lexicographically largest string from box 1. So this is from the latest contest of lead code, that is weekly contest 430, and we the question is actually very simple, very easy, but the language by how it has been provided is pretty tough. It's like mm, how the language is like how your teacher explains, how your professor explains something to you in the class, and it can be given in a language that can be easily understood. Like your friend just uh, explains you everything one day before the exam. It can be given in that language also, but I think is it intentionally given in such a difficult language, or they have somehow mistakenly made the language too much complex? That's why you can see that the acceptance rate is not too good, although it is a medium level question, right? So acceptance percentage, acceptance rate, right? So let's understand the question. So you will be given a word that is a string type and an integer num friends. Num friends is actually how many friends you have, and the word would be split among all those friends. And after splitting the word among all those friends in each and every possibility, you need to return the lexicographically largest string. What does lexicographically means? Graphical means the order you see in the dictionary. That order is called lexicographic. Suppose you think you should remember two things, like this is a cheat code to remember what lexicographic means. You should remember two things. First one is the largest character, and the second one is the length, the largest length. The first should be given the first priority, and the second should be given next priority. So if I talk about this, right, I talk about this thing. uh, okay, so suppose A is a character and A, lexicographically they are equal. If I say AB and AA, this is lexicographically greater, because first of all it actually compares character by character. First of all, this A will be compared, they are same, so no problem. Let's go to the next one. B and A, B is greater than A, right? B comes after A, B is greater than A, so lexicographically this is greater. Another thing to consider is if both of them are same but one length is greater, then the greater length will be considered. This is lexicographically greater because after these two are compared, it still have one character left. So the length that is greater, it will be considered lexicographically greater. So what I can see from here, that what does lexicographic means? Lexicographic means two things. One is the thing that is, it should have the largest character, and the other thing is it should have the largest length after the character is same. If the character is same, then it should have the largest length. So what you can see is this is the word given DBCA and the number of friends is 2. Mm, so we can see that we should return the lexicographically largest string after splitting it in all the possible ways to two friends. And another thing you should remember that any student cannot have a empty string. Every student should have at least one character. So can I like think it in this way? Suppose I wanted, can I write it in this way that okay, I have A B C D B B B D A D D D A D. So this is my string, and my I have friends equals to I have 10 friends. So what you can see is I the minimum I have to give. I need to find the lexicographically largest, right? So we have already seen one condition is the length should be greatest. To make the length greatest, what I can do is I can give every 9 friends one character each, and I will be left with 1 2 3 4 5 6 7 8 9 12 13 15. I am given 15, right? So I'll be left with 15 minus 9 equals to 6. I will be left with 6 characters. So what you can see is the maximum I can give to one friend is a length of 6 characters. So the formula, how I came up with the formula? So first of all, you should think it like, you should intuit it like that. You should be giving uh, each friend one character, and after giving each of the friend one character, the last friend should be giving all the left characters. So the formula would be mm, the length of the word minus the number of friends plus 1. It is like n minus friends, and how many friends I have given one character to, how many friends I've given one character to, f minus friends minus 1, this many friends I have given one character, and how much I left with, the length of the word minus this many. So this minus gets multiplied inside and I get this formula, that is n minus number of friends plus 1. So this is my possible length, this much largest length I can give to one character. And then what you can do, you need the lexicographically greatest, right? So then what you can do is you can find, okay, what is the what is the largest character that is present in this? You can see D is the largest character. D is here, D is here, D is here, D is here, D is here. So we can see that lexicographically largest character, lexicographically my largest string can start from this D and go up to the 6th length. It can start from this D and go up to the 6th length. It can start from this D and go up to the 6th length. So what can we do? We can actually A, B, D, A, B, D, D, A, A. What can we do? Of suppose I have considered here the length is 3 for easiest sake of understanding. So this can be my lexicographically greatest. This can be my lexicographically greatest. This can be my lexicographically greatest. And if here is a D, uh, DB as well, this also can be my lexicographically greatest. So what I will do, I will store each of the indices of where the largest character is present, and then I would actually take the slots of the length of the largest character, and after that what I will do is I will compare each one of them. After comparing each one of them, I will get the largest lexicographical string. So how the code will look like, I'm going to compare each one, right? So you can also compare character by character, but character by character comparing would take a lot of time, and it uh, actually we are actually given up with a function that is named compare to. We can use that by not actually comparing character by character. So what we are doing is, first of all, see, I have used the variable n to count to store how much the length of my word. I don't want to write word dot length every time. That's why. So if I have got one friend, so I need to give every character to my that friend only. So I don't need to perform everything. I just can simply return my word what I have been given. If my friend is one, so then what can be my possible length? My possible length can be n minus circumference plus 1. I have already shown you the formula, right? So now I am assigning, so it is already given in the constraints that the word the word will always consist of lowercase English letters. So that's why I have taken ch will store the largest character that is present in the whole word string. So for that reason, I have taken ch as a. I have taken the lowest possible character that I can take that is present in word, so that if the word would contain only a will be the largest, and if it contains anything greater than a, my largest will be that thing. I am storing the current one, the current index word at cur, and if cur is greater than ch, then ch is equals to cur. Ch will store the largest one, and then I am using a array list, for storing the indices of the largest character. I will traverse the whole word string again, and if my current character is equals to the largest character, then I will add the indices to my LL array list. Then okay, then it may look a little bit confusing, but be with me, you would get it. String builder. Why am I using string builder? You can also use string, but string builder is it is faster than string. It is efficient than string. It is mutable, right? String is not mutable, but string builder is mutable in Java. So that's why I am using string builder. So string builder largest. So this will store my lexicographically largest string, and I'm for the first time I'm assigning with, I am getting the first indices of the largest character, and I am actually getting to the possible length. If why I have given this question mark here, because if the possible length, if somehow it exceeds the length of the word, then it should be n. So if I go to the paint again, and what I can do is selection, right? Select this whole part and erase. What happened? What happened in here? I don't know. Let's erase this thing. This can't be done, right? Oh, it got stuck. happening here? We need to consider another thing, to consider another paint for this. So hang हो गया लगता है laptop. Paint, right? So what you can do is A, B, D, D, A, D, R, C, C, A, D. So what I am storing in the largest for the first time is I'm getting the array list in the 0th index will contain this index, and I'm going from this index to up till the possible length. And what I'm getting is I'm storing this substring, this total substring in the largest for the first time, because this can be the largest for the first time, right? And then what I have given, if the if my possible length is suppose 5, and a b d uh, a a a c. So if this is my thing, then my first index will be this, and if I would like to take this much substring, it won't be there, it would be um, like array out of bound index. So if the pl is greater than n, then give me the n, then give me dc. For that reason I have actually um, written this condition. If it is less than n, then okay, take it, or else take n for the first time. And then I would be like taking all the indices of the from the first indexes, because for the 0th index I have already, for the first largest character I have already taken that part. And for the new string I would be storing current string to here. I have assigned current string as empty. Now I am storing current string, new string builder, what dot string. I would get the next one, right? Here is the same condition is given, so I would take the next one, bdda, and here it will have by. I have taken b here, ddad. This is my largest. Okay, okay, say this, a b d a d d a b d. Suppose my possible length is 3, so for the first time it is this is stored in the largest, and I am getting this as the current, and this thing, these two will be compared, and here you can see current is greater, the compared to function. Here see the current, I'm storing temp current string dot compared to largest. If current is greater than largest, then it will give me some positive result. If both are equal, then it will give me 0. And if current string is lesser than largest, then it will give me negative. So if temp is greater than 0, actually reinitialize largest to current string. What is happening here is, here you can see current is greater than largest, so I will get a positive result. And now my largest will be not this and this. And after iterating the whole length, I will get what I will get. I will get the lexicographically largest string, and my job is done. I can return that, and voila, your job is done. So return it, and it looks a bit like what you can say. a bit complex, but I can show you another easy way also. A B D D A D C A A D. Here what you can do, you can take the substring lengths. You can start from the possible length. Suppose 3 is the possible length. So what you can take, first of all, you choose this as the largest, then you start iterating from the first index, then you choose this as largest, then you started iterating from this one. So if you compare both of this will be largest, right? My current will be largest, so this will be assigned largest. Next you will compare with this one, so this will be my largest, so again this is my largest. For the next time I will compare it with this one. Oh no, this will be my largest income. By comparing it, like for the whole array, slot by slot, like a sliding window, you can also check it, because your possible length will always be 3. And if you don't store the indices of the largest character, it's okay, because you are checking for every indices, and for every indices the largest character will also work. So for if you will check for every indices like that, you will at last store the lexicographically largest string of the possible length, or smaller than that if my d like is at the end, right? So this can also work as an order of big of n. So if I will talk about what will be my order, what will be my time complexity and space complexity. Suppose for this thing, this is big of n, this is big of n. First of all, I'm calculating the time complexity, and for this thing what you can get is again big of n at max, because if I have all the characters as the largest character, then it will traverse the whole array. So big of n plus big of n plus big of n, uh, big of 3n. You can also and the space complexity, right? If I talk about the space complexity, if every character is the largest character, suppose it has d like that, then what will be my uh, array list size? My array list size will be big of n. So my space complexity is big of n here as well. But if I talk about the second approach, if you can quote the second approach, it will be big of mm, big of n for time complexity, and it doesn't consumes any space, so it will be big of 1 for space complexity. So we can optimize the space for it as well, and it works for big of n because it is 5 into 10 to the power 3. It will work fine for big of n. If I go to the solution, if I go to this one, it's 70%, right? Can we see something better than that? 5 millisecond, 15 millisecond, 5 millisecond. So here max index, if n is equals to return is okay. Max index is dot length minus 1. Couldn't. Okay, I cannot get what is it mean. Okay, so this problem is solved, and it is a pretty easy problem, but only the language that has been used in this question is not so friendly.